The Marriott Resort in Honolulu faces rising electricity demand, high utility costs, and increasing pressure to operate more sustainably. Like much of Hawaii, the resort relies heavily on grid electricity generated from imported fossil fuels, making its energy supply vulnerable to price volatility and external disruptions. To address these challenges, three solar panel layout designs were developed. Why is this important? It's because this approach does more than solve a site-specific power issue. It contributes to a larger sustainability goal, and by generating clean on-site electricity, the resort can reduce fossil fuel consumption and dependence, lower long-term operating costs, and decrease greenhouse gas emissions. Projects like this also support Hawaii's broader transition toward 100% renewable energy by 2045 and demonstrate how commercial properties can play an active role in building a more resilient, affordable, and environmentally responsible energy future. Let's move on to the designs. These designs focus on the use of solar panels to help with Marriott's power problems. These three designs will help visualize this transition. So first, I would like to go over the design parameters that were followed for each of the designs. The first parameter was that the solar farm had to generate at least 1 gigawatt hours of solar energy annually. Secondly, the design can't have more than 2,500 solar panels. And thirdly, trees had to be used to reduce panel visibility of the solar farm. And lastly, all the solar panels used should have the same specifications. With that being said, let's go over the different versions of solar farms that can be implemented. Version 1 is a solar farm on Marriott's parking lot. This version provides the resort with solar power and shade for its residents. Version 2 is out of the way of residents and makes use of adjacent land as its space for solar units. Version 3 is out of sight of residents and is highly expandable because it's on a separate piece of land. And let's move on to how I tested these. In testing, these three versions were subjected to yearly yield simulation analyses on Aladdin. The most effective version was version 3, with each panel producing 539 kilowatt hours for the year. For future versions, it will include all three ideas. There will also be changes to each panel specifications to improve efficiency, such as its angle of tilt, the spacing of the panels, and its orientation. I would also like to note that this work will not only move toward a more self-sustainable Hawaii, it will also help lessen the use of fossil fuels to the benefit of our planet. And here are my references. And I would also like to thank my professor, Aaron Hanai, for giving me the guidance for me to complete this project. Thank you. Any questions?